Hello, everyone, and welcome to our webinar, The Benefits of Implementing a Holistic Automotive Management System. Your speakers for today would be my colleague Dusan Nikolic and myself, Hisham Deborah. Just to give you a bit of a background on both of us, Dusan is our Technical Business Development Director for the automotive sector for SGS North America. Dusan is a certified third-party auditor for IATF 16949 with over 30 years of experience in the automotive industry, working with OEM Tier 1 suppliers. He's held a number of quality and engineering management positions with several key industry players in Canada, the US, and Germany. As far as his educational background, Dusan is a mechanical engineer and has worked as a professional engineer in the province of Ontario. A little bit about myself, Hisham Deborah. I am the Regional Sales Manager for Industrial and Transportation. I work with companies within the automotive, aerospace, and industrial sector to provide supply chain and quality compliance solutions to ensure that they are safely and efficiently integrating their business operations on both sides of the border, US and Canada. I have over 13 years of experience within sales and 4 years of experience specifically within the certification world. A little bit of background on our company. SGS has been the world leader in the testing, inspection, and certification industry for quite some time. Company was founded in 1878, so we've been around for a while. We have a little bit over 97,000 employees currently, with 2,650 offices and growing. Some of the services that we offer with our consultative services division, what we like to call knowledge solutions, ranges from everything from certification to training, customized audits, our supply chain risk management system, Transparency One, as well as just overall technical consulting. And if you aren't already convinced as to why you should choose SGS, here on your screen are some of the differentiators that make us stand out when looking at us in comparison to our competition. We definitely have the industry experience, been around, as I mentioned, for over 100 years. We have the largest global footprint in terms of resources, and quality of service is something that we highly value. So we ensure that every interaction is met with the highest quality, and we like to work with you as a partner to ensure that you get to where you need to be. And with that, I'll hand it off to Dusan to take us through our agenda.
Good morning, good afternoon, everybody. Let's go quickly through agenda of today's call. We're going to talk about industry technological trends, some common automotive expectations, review of automotive customer requirements from some major OEMs and Tier 1s. We're going to cover automotive sustainability driving principles. We're going to talk about automotive management systems, automotive integrated management systems, the way we see it. We call it holistic automotive approach. We're going to show an example of such a holistic automotive management system, and I will show you some examples of how to integrate some additional OEM customer requirements like functional safety ISO 26262, ISO 21434 covering cybersecurity in the automotive, ASPICE, software management tool, and TISAX, Trusted Information Security Exchange, promoted by German OEMs. Looking at the history over the last, let's say, 25 years, I have a timeline here showing 1999 up to 2022. The early systems were just warnings. Let's pick just a few: forward collision warning, lane departures, rear cross traffic warning, cruise controls, and so on. So they were just warnings. So in essence, they would just blink on your dashboard and basically warn you of certain um, departure from normal driving. Over time, that has developed to assist features. Basically, the warnings were not only warnings. In addition to warnings, they would basically assist you to move away. Let's say from when you depart your lane, it would stop your vehicle if you have a sudden obstacle in front of you and so on. The future, or even current cars, some high-level cars like Teslas and some other cars, who have so-called autonomous driving as an option, have all those systems now basically fully engaged and basically driving your vehicle while you're almost as a bystander behind the wheel. This trend will definitely continue with new technologies coming on board, and as all these technologies become standard for the vehicles to come. Vehicle-to-vehicle communication, vehicle and cybersecurity is going to become very important for those OEMs, as of course they have to use the network and GPS and all the radars and other cameras to basically make sure that they have the right picture of the surrounding of each vehicle. I'm sure that you will agree with me if I say that Teslas of the world have clearly changed the automotive landscape. The other OEMs, even if they're not quite sure what happened, feel the change, feel the shift, and know they need to respond. So what we see currently is a race amongst the OEMs to add more intelligence and sophisticated electronics into a vehicle. The suppliers and OEMs are often collaborating to innovate and stay ahead of the curve, enabling open communication and a flow of ideas between vendor and customers. Suppliers become innovation partners, not just fillers of POs, for example. Tier 1 suppliers are doing more and more integrations so they can deliver more complete system instead of just major components. So what we're seeing is that OEMs are going to ask the Tier 1 suppliers to deliver the integrated systems, the modules, for any new e-mobility challenge that they see. For example, Magna and Aptiv have been doing that for years now. They're called Tier 0.5s because they're not Tier 1s. They're basically working closely with OEMs, so they're in between, delivering to the OEM. So to make this transition, OEM purchasing managers face a few options: continue to work with the same suppliers in hopes the vendors will innovate and deliver, or find new suppliers specialized in manufacturing electric parts. Suppliers have all the capabilities to create the current components needed for internal combustion engines. So how can they use the same capabilities to create the electric drive trains? Something needs to change. The emerging technology can change so quickly that it's difficult to keep up. By the time OEM learns a new technology and how to implement it into the supply chain, the technology is already old by these standards. This is why they will turn to the suppliers who are able to adapt quickly to ever-changing environment. In the traditional sense, where each component was somewhat siloed, these barriers are coming down as departments educate one another to the latest and greatest trends. The OEM purchasing division must really interact closely with the engineering side. So basically, the requirements are visible across the entire supply chain. With the OEM sourcing managers armed with the knowledge of evolving technologies, the challenge for the OEM and suppliers is how to stay ahead of the curve. As the supply chain can influence a business success, the risks associated with choosing the right supplier becomes a key business decision. I'm sure we're all aware of that. We know that over the past 4 or 5 years, safety has become the big thing with ISO 26262, functional safety for automotive vehicles. And we have some other standards here as well. A lot of technology is actually developing this area. So naturally, because it's electronic, it's a computer, it's an open network, security is a thing that it's coming together, and you can't really detach safety and security. They're all tied together. With the exception of Tesla, most automotive companies have a fragmented supply chain model. So making sure to check all sustainability boxes that I list here is very important to be able to be perceived as a trusted partner. So competencies, compliance to industry standards, change management, staying ahead of the curve, as we call it, resource, the competence, of course, customer service, quality issues. Furthermore, environmental pollution. The OEMs have become very strict in choosing the right supplier that basically is making sure that they don't add to global warming. Shortages of raw material, natural resources, workforce health and safety incidents, absolutely. Workers' satisfaction is very important. Their awareness and empowerment, as we call it. Labor disputes, mechanisms about that, corruptions and bribery have to be addressed definitely, and of course geopolitical consideration. Those are all basically sustainability boxes that each supplier has to take into consideration when approaching an OEM for a new bid. In this slide, I took snapshots from several OEM and tier ones, and before I go into details, I want to just make sure that you understand the difference between customer requirement and customer-specific requirement. So according to IOB, customer requirements refer to those that focus on or are specific to the order of product. So they're not usually related to IATF 16949 standard. And these requirements are only specific to this customer. On the other hand, customer-specific requirements are those that are basically coming from OEMs to supplement the IATF 16449. So reading here, Honda, for example, ISO 9000, IATF, ISO 14001, 26262 as a functional safety. Below that, we have purchasing terms and conditions, IATF, ISO 14, so environmental, ASPICE, software development tool. BMW, we have CO2 reduction. So basically, they want suppliers to be environmentally responsible, socially responsible, and governance, basically ESG for short. General Motors, again, compliance, commitment, and growth with regards to environment and so on. I wanted to bring to your attention that AIAG has released a document called Automotive Industry Guiding Principles to enhance sustainability performance in the supply chain. You see all these companies who've signed up on this guiding principles, on this document. In a message, the IAG and these companies are saying that automotive industry supply chain has a high degree of complexity, and therefore they believe in the benefits of a common approach and message where possible. These automotive sustainability guiding principles contains certain expectations towards business ethics, working conditions, human rights, health and safety, environmental leadership, and supply chain due diligence for suppliers at all tiers. They expect suppliers to uphold these standards and cascade them throughout the supply chain. The guiding principles define common expectation of the signatories for the suppliers. To fulfill the guiding principles, automotive suppliers should implement a management system or systems defined as a combination of policies, processes, functions, tools, and internal controls that help an organization control its operations, reach objectives, and ensure continuous improvement. The recommendation concerning the practical application of the guiding principle are outlined in the practical guidance. So I urge you to download this document. It's very interesting, and I'm sure we can all learn from it. So when we follow the guiding principle that I showed in the previous slide, the expectations from the OEM is that companies basically uphold the highest standards in multiple areas: business ethics, environment, human rights and working conditions, health and safety, and responsible supply chain management. So several things: anti-corruption and anti-money laundering tools need to be in place, data protection and data security, disclosure of information, conflict of interest, counterfeit parts, protection of intellectual property, export controls and trade and economic sanctions, grievance mechanisms, carbon neutrality for environmental, water quality, consumption management, air quality, responsible chemical management, of course, animal welfare, biodiversity, land use and deforestation, soil quality, noise emissions, and so forth. So when we talk about automotive sustainability guiding principles, needless to say that a certain quality management system and certain management system as a whole address several aspects of the sustainability aspect. So, for example, quality. ISO 9000 or IATF 6949 are quality management system, basically handling the product quality or service quality, for that matter, when dealing with ISO 9000. Software process, ASPICE, stands for Automotive Software Process Improvement and Capability Determination. Is of course used in the automotive market for, as we call it, embedded software that we see nowadays in every vehicle. Safety requirements, ISO 26262, road vehicles functional safety. It is an international standard for functional safety of electric and electronic systems in automobiles. 21448, safety of intended functionality. It's a next step to 26262. Of course, cybersecurity nowadays is very important. There's a standard covering the requirements for suppliers. ISO SAE 21434, road vehicle cybersecurity engineering. TISAX or TISAX, basically trusted information exchange, not covering only OEMs, but basically everything that surrounds OEMs. So any prototype data, any data that is exchanged between OEM and surrounding companies dealing with the OEM. Finally, ISO 27001 is an information security management system. It's very similar to TISAX, but it's not the same. So in the previous slides, we covered ESG, automotive sustainability, environmental, social, and governance principles. We understood that OEMs sustainability focus is business ethics, environment, human rights and working conditions, health and safety, responsible supply chain. So I don't think it should be a surprise to everybody to see here listed several standards that automotive suppliers should engage with or should be looking to be compliant to make sure that they make a strong case when approaching the OEM for new business. So just several here: 1401 environmental, 4501 occupational health and safety, 5001 energy management systems, then greenhouse gases, social responsibility, asset management, anti-bribery management, just to list a few. So when we list in a table like I did here all these standards that we talked about, we can distinguish them by two aspects. So-called ISO basically defines Type A management system standards that contain requirements against which an organization can claim conformance, where Type B management system standards, they do not. Also, harmonized structure. We talked about in previous webinars about high-level structure. So where we have HS listed for each of these standards, we talk about the same structure that some of these ISO standards have in common. So if you recall clauses, let's say 4 is context of organization, 5 is leadership, 6 is planning, 7 is support, 8 is operation, and so on. All these clauses basically are the same across all these standards. Of course, the requirements are different as they have different scope, quality versus environmental versus health and safety, but the standard structure is the same, and this is where suppliers can basically find themselves in familiar waters, so to speak. Now that we understand that several ISO standards follow the same high-level structure, and knowing that OEMs requiring their suppliers to very often be compliant to these standards and certified to these standards, it is beneficial for suppliers to do the integrated management system approach instead of, as we call it here, piecemeal, building one by one. So by building an integrated management system approach, they can benefit across the organization, basically save the time, increase efficiency. The processes that they build can, at the same time, fulfill several requirements across each of these standards. So a different way of showing the integrated management system approach or holistic automotive management system approach, I show on this slide, different scopes, different focuses of different standards that very often have common requirements. Quality with IATF, safety, ESG, environmental health and safety, and security, as shown here with their applicable standards listed on this slide. I will give you a moment to read all this, but there's multiple benefits of basically following this holistic approach. Establishing consistency, redundancies, removing redundancies, reducing costs, optimization of processes and resources, consolidation of audits. You can have integrated management system audits, better decision making as you understand things across multiple requirements, reducing bureaucracy, and so on. So when talking about components of any management system, not only automotive, there are several essential components that needs to be clear for the system to function efficiently and effectively. Objectives, the processes, of course, organizational structure and resources, and performance feedback. This is the PDCA cycle we very often hear for a management system. So in general, why the system exists? It's usually to satisfy the needs and expectations of interested parties. You will hear that very often in ISO 9001 based systems. The basic principle of a management system is understanding the context in which the organization operates, and by understanding and examining its external and internal issues that determine the system's success and sustainability. So the management system exists basically to fulfill the requirements and to address and control any external and internal issues that can basically limit the effectiveness or efficiency of that system. So the organization has to plan the processes around the management system, not quality. In order to control their external and internal issues, they then implement, plan, monitor the efficiency and effectiveness based on data, and make appropriate adjustments as we mentioned with the PDCA cycle mentioned earlier. We mentioned earlier that we have high-level structure that's common among several of management systems. I show here environmental, energy, quality, information security, and operational health and safety system that all put together create an integrated management system. So the integrated management system and all these separate standards have common nomenclature. So 4.1, understanding the organizations and its context, understanding the needs and expectations of interested parties. Of course, interested parties can be same or different. 4.3, the scope of the management system. Sorry, I said here quality. I'm thinking more of integrated management system. Then 4.4, integrated management system and its processes. The organizations have to develop the processes that basically satisfy requirements within each of these clauses. And number 6.1, very important clause, actually, when planning for integrated management system, the organization shall consider the issues referred in 4.1 and requirements referred to in 4.2 to make sure that the risks and opportunities are addressed properly, and we have a functioning management system in place. So going further with this example, I wanted to show you, this is a simple company that wanted to integrate several management systems as required by their customers. So they're integrating ISO 9000 with ISO 14 environmental, 2701 information security, 4501 health and safety, and 5001 energy management systems. The top column basically has the same verbiage, only the scope of the system is different. So, any internal and external issues that I listed here in this table can be the same, of course, across multiple systems, but don't have to. Just for example, internal issues for quality management systems are, let's say, human aspects, infrastructure, operational factors. External issues are suppliers, social factors, competitiveness, technology, and so on. Let's skip to 2701, internal issue, information system, information flow, external issue, contingencies, and technical advances. You know how much company wants to implement the new technologies that are available, and going to the end to energy management system. I'm sorry. External issues, again, technology, legal, environmental, and internal issues, operational factors, employee knowledge, vision and mission. Where does company see themselves as a factor in our economy? So going further, clause 4.2, understanding the needs and expectations of interested parties. So we now know the interested parties. We want to know what are their needs and what is their expectation for each of these management systems. I keep saying quality. I'm sorry. So interested parties relevant to, for example, quality management systems are, of course, customers, end users, owners, and so on. And their needs and expectations are, of course, customer requirements regarding conformity, so quality or delivery, statutory and regulatory requirements for the product or service, contracts for external providers, return on investment, absolutely. Skipping to, let's say, 4501, of course, interested parties are employees, owners, customers, regulators, visitors, contractors, suppliers. Needs and expectations, we have to make sure that the legal requirements are met. Making sure that adequate training is for competence and for any health and safety issue are in place. And of course, requiring our suppliers to have similar objectives in their management systems. Going to 5001, for example, is again employees, owners, customers. So interested parties are very often same across multiple systems. Their needs, of course, can be the same, but don't have to be same. It's usually focused on the scope of the management system. So for energy, of course, protecting environment, network capacity, minimum energy efficiency standards, and so on, are expectations and needs of certain interested parties. As stated earlier, all work in an organization occurs through its processes. So any organization should have a deep understanding of the timing, interdependencies, interactions, and interfaces within the processes of the organization's management systems. We know that processes need to be both efficient and effective in transforming inputs into outputs. The best way to present the process is through, as we call it turtle diagrams, where basically you have inputs, then process itself, and then output with several branches for people, so jobs, responsibilities, materials, information, infrastructure, competencies, and other resources, and the measurement of the process performance. I show here a very simple management system where we show in 3 different colors: core, operating process, MOP, management processes, and support processes in yellow. So let's study further our example that we show in previous slides. So having the integrated management system with the processes that we listed in the previous slides, the organization we look at developed the following process. I show them here on the left side in green color. Planning and risk management, operations, leadership, monitoring and measurement, internal audit, corrective action, and improvement. It basically follows that PDCA cycle we talked about many times. So each of these processes would satisfy or address requirements that each of these management system processes have under under those clauses. You know, planning and risk management is one of the requirements of each of these standards. So quality management system has its scope, has basically has actions that that are put in place to plan and address the risks and opportunities, developing quality objectives, EMS, environmental aspects, of course, ISMS, information security, operation health and safety, hazard identification, assessment, and so on. Operation, of course, for quality management system is product quality. For EMS is emergency preparedness and response. For ISMS is information security risk, assessment and treatment. For operational health and safety, eliminating hazards. For energy management system is energy performance improvement and so on. Similarly, for leadership and training, we can say that you know, the requirements are almost the same across the board, because roles, responsibilities, and resources and competencies and awareness, they have to be addressed by the leadership of the organization. Monitoring and measurement, of course, you know, we have different scopes, different view of the requirements. For QMS is a QMS performance. For EMS is evaluation of compliance. For ISMS is effectiveness of the ISMS. Going further, internal audit. Of course, internal audit is required across the board. So internal audit can be basically simplified and you know, looking at basically compiling several requirements under one internal audit. Similarly, corrective action and improvement is a requirement across all of these management systems. So using a unique approach, or using a simple or single approach to addressing all corrective actions that are needed across all these management systems is the way to go. So to further examine this example we talked about, I want to remind you what I said under 6.1 clause in previous slides. So when planning for the integrated management system, the organization shall consider the issues referred in 4.1 clause and the requirements referred to in 4.2 clause, and determine the risks and opportunities that need to be addressed. So on this slide, I show on the left interested parties in the light green color, and horizontally interested parties' needs and expectations. So interested parties, owners, shareholders, customers, suppliers, employees, and their needs and expectations for different aspects. So financial benefits, ethical behavior, customer requirements, risk control, supplier partnership. Of course, this example can go further, but this is just to show you how to approach this element. What we can do is basically cross-reference each interested party with their specific basically needs and expectations. So if we cross-reference owners and financial benefits, of course, risks are no returns on investment, reputation loss, opportunity would be diversifying, of course. For customers, let's go to ethical behavior as a need. For customers is knowledge retention, competence, business interruptions, opportunity, definitely employee empowerment. For supplier and, for example, customer requirement, we're going to say customer-specific requirements not met as a risk. Risks are processes and systems not in place. An opportunity, of course, to have a reliable supply chain for the customer. Finally, employees and, for example, risk control as a need. Employees, of course, have to have a sustainable long-term, employment. Risks are legal requirements or not meeting the legal requirements, I should say, not meeting the customer requirements. And opportunities is definitely one of the opportunities protecting investment. So this approach will show you how to basically align different interested party across different management systems. And, you can have same needs and expectations that will satisfy several management system requirements when you use the integrated management system approach. So in the previous example, we show a multiple management system and how do we basically integrate them. What I wanted to do here is add some additional customer requirements that we saw in those previous slides, where, for example, 26262 as a functional safety requirement is one of the requirements that we saw in OEM's list of requirements. What I show here is, of course, you will recognize APQP process. So APQP process is, of course, a core tool that's used in automotive industry. So what we can say is that, the quality standard is a prerequisite to ISO 26261. It is basically expected to understand that all processes under ISO 26262 must be implemented in the quality management system. So let's say the functional safety product, we need to, of course, develop it under umbrella of the quality management system. That's one of the clauses in IATF. What else we can say is all these requirements through different parts of the 26262 are very similar to what APQP has already described as deliverables for different milestones. I show here, initially, of course, plan and define with the concept phase, HARA definition, functional safety concept, then going to the product design and development and process and design development. Similarly, 26262 requires to follow the similar methodology, where we first develop the system level design, and then we go down to hardware and software level design, and finally in production, operation, service, the commissioning, with several supporting processes, of course, on assembly instructions, tolerance, calibration, anything that we would normally build under any quality management system. What else can I say about 26262? The process is based on automotive safety integrity levels. We call them ASIL levels. It's basically a risk classification system, and the objective is to reduce potential hazard caused by electric or electronic system malfunctions. So again, building the requirements on the backbone of quality management system is a preferred approach to meeting the requirements. So just as an addition to the previous slide, as we already have quality management system processes, I pull the processes from the previous example we had. The requirements are already visible in the quality management system. So cross-referencing requirements under QMS versus 26 or functional safety standard, we can basically build processes that satisfy both quality management system and 26262. So in this example, under, let's say, planning and risk management, quality management system process, under quality management system, we have to demonstrate conformity to product requirements. Similarly, 26262, there's an impact analysis, there's a planning stage, and there's a basically implementation stage where we build assembly instructions, tolerances, and so on. Leadership, training, and competencies. The quality management system has clear requirements for that. So does 26262 with process to ensure that identify functional safety anomalies are explicitly communicate to the applicable safety manager and other responsible persons. It's implied that the safety manager has the competencies to address the issue. Corrective actions and improvement. We know that QMS has requirements for that. So does 2626.2. So again, I reiterate that building or designing the process, quality management system process can fulfill several requirements of not only quality management system, but requirements of other standards that are built on the backbone of the QMS. In this webinar, I want to cover several more standards that appear as requirement in OEM slides we reviewed earlier. So 21434 considers cybersecurity as a specific automotive engineering discipline and sets criteria for vehicle cybersecurity engineering. The standard is applicable to the road vehicles, systems, components, software, and so on. The standard is intended to address cybersecurity for road vehicles in a way similar to which ISO 26262 functional safety does for functional safety. ASPICE, or Software Process Improvement and Capability Determination, is a standard used as a framework for improving and evaluating process in the automotive domain. The IATF 6949 is mainly concerned with the quality management system processes from the organizational level. The automotive SPICE focuses on assessing the capability and maturity of the organization's core process from the project perspective level, so software, project software. In both frameworks, all processes have been organized according to the B model, in such way that each process on the left side corresponds exactly with one process on the right side. B model we presented in one of the earlier webinars, and 26262, 21434, they all follow the B model as a methodology. Similarly to the previous slide, I put here side by side the quality management system, functional safety, cybersecurity, and ASPICE requirements one next to another. I, of course, put processes that we showed in the example earlier. And again, I want to repeat that the process, the way you design your process, can basically fulfill the requirements of multiple standards, not only quality management system, IATF or ISO 9001, but also all these additional requirements that OEMs are currently asking us all to do. So 26262, design and development. In QMS, we have requirements for products and services. In 26262, we have concept phase, system safety requirements. 21434, again, requirements for cybersecurity management. ASPICE, conformity requirements. So, very, very similar intention in all these standards. Planning and risk management, we covered that. Risks analysis. 26262 again talks about risks. 21434 and the ASPICE as well. Let's go to the bottom. Corrective action and improvement. Problem solving is one of the key elements in the quality management system. Similarly, 26262 has the same requirements. 21434 and ASPICE. So again, building a process, a quality management system process that can address risks and opportunities and needs and expectations of all interested party is the beneficial way to go. The last several slides that I want to dedicate to cybersecurity. On the slide here, I show sanctioned interpretation from IATF 16949 clause 6.1.2.3 contingency planning, OEMs are currently requiring their suppliers to be very vigilant when dealing with cybersecurity. They want to make sure that any information exchange between not only product as assembled on the vehicle when communicating to the network, which the standard previously talked about 21434 covers, but also when talking to their suppliers during the prototype builds, any CAD exchange, any data exchange with the suppliers have to be safe from any cyber attacks. This is an intro to TISAX, as we call it, Trusted Information Security Exchange, and that is becoming a norm in North America. Not only it is actually a German standard, but it is becoming a norm in North America. So if you want to make sure that you address this as a requirement in front of the customers, the suggestion is to take the assessment. In this slide, I drew a comparison between ISO 2701 and TISAX. 2701 is Information Security Management System. TISAX, on the other hand, is a system where OEMs like German automotive companies, BMW, Daimler, Volkswagen, and so on, mandate compliance to TISAX. So they have to be assessed against the requirements to be able to bid for any new business. It is actually considered particular customer-specific requirements for German automotive OEMs. And tier ones are basically being asked to make sure that their cybersecurity systems or information security, I should say, systems are addressed against the requirements. As I said, although TISAX is a German standard, currently it is globally recognized and therefore also applies to foreign suppliers who wish to do business with the German automotive industry. The last information we have is that this standard is going to land here in North America as a requirement for other automotive OEMs. With this slide, I want to thank you, and we're going to go back to questions and answers after.
Thank you, Dusan, and thank you, everyone. Once again, on the screen there are some of our training courses that you can register for through our SGS Academy. And we do also have an upcoming TISAX training on March 28th for a public virtual training session. You can find the link to register for all of these in the resource section on your screen. And if anyone has any further questions, please don't hesitate to get in touch with myself or with Dusan. We'd be more than happy to assist and get you signed up or point you in the right direction. Thank you once again.
Thanks, Hisham. I see a few questions posted here in the chat screen. I want to answer them before we close the webinar. Question number one, is SGS an approved TISAX assessor? Yes, SGS is an approved TISAX assessor in North America and in Europe and worldwide for that matter. So yes, please, if you need any service arrange with us, contact us. Question number two, can SGS provide consultancy or gap analysis for ISO 26262 and 21434? That's a little bit complex question. So SGS is an accreditation body, so we do audits. We shouldn't be consulting and then auditing the same client. For this, we have our partners who are basically more than capable to provide consultancy and gap analysis. Basically, these are engineering companies that work with OEMs, and they can build or help you build a system in accordance to requirements. And at the end, we would come in after everything's built. We would come in and audit those systems. So full service, I guess we can call it that, is an option for you. Another question here is, do OEMs mandate certification to ISO 1401 and 4501, 14 environmental, 45 health and safety? If you recall, in one of the first slides, I said these are customer requirements. So customer requirements, if your customer has specific, customer requirements to be compliant to 14 or 4501, then in that case, yes, they become your requirements, and you should find a way to be certified to them. You will definitely get additional points, additional bonus points, and they would probably push you up on any bid list that for new business. I don't know. I don't see any other questions. If there are any other questions, please feel free to post. If not, Hisham, I think we can close the webinar. Thank you for your time. Thank you for listening. If you have any questions, as Hisham said, you have our email addresses. Give us a call. We'll be more than happy to help your path towards being compliant to all these new standards are coming our way. Thanks.
Thank you. Thank you, Dusan. Thanks, everyone.